Hello students, welcome back to maths class. So today we will deal exercise 9C. From differentiation we are having one long question, one 4 marks question, two very short answer questions. Okay, so that's why we have to do lot of problems. And next application of derivative one topic is there, lengthy topic. From that we are going to have 22 marks. So that is entirely based on this differentiation. Okay, so be attentive with the differentiation. All the formulas, all the basic things we are getting in this differentiation, we will follow in the application of derivatives. Okay, so now come to your first question. Find the derivative of. Today we will solve all the 5 questions, right? So these are nothing but 2 marks questions, and observe what is your first question. Whatever be the given function to you, you consider that as y. So y is equal to, what is it? It is sine inverse of 3x minus 4x cube. So if it is y is equal to sine inverse of something, we can easily solve the problem by using our direct differentiation formula. But here 3x is there, minus 3x cube is there, minus 4x cube is there, right? Whenever we are having the problem or question or function in complex form, we will go to substitution method. I already said to you, whether it is 4 marks question, whether it is 7 marks question, whether it is 2 marks question. Suppose the given function is in complex form, convert it into simple form by using your substitution. So here you substitute, put x is equal to sine theta, right? Put x is equal to sine theta. Then what happens to your value? Y is equal to sine inverse of, what is that? 3 sine theta, right? Minus 4 sine cube theta. Okay, there is one standard formula in trigonometry, 3 sine theta minus 4 sine cube theta is equal to, it is sine 3 theta, right? It is the standard trigonometric formula. 3 sine theta minus 4 sine cube theta is equal to sine 3 theta. So we can write this as sine inverse of sine 3 theta. Okay, so sine inverse sine will get cancel, is equal to 3 theta we will have. What is your theta? Observe from this, if you send sine this side, you will get your required theta. What is that? Sine inverse of x is equal to theta. So we can write this as 3 into sine inverse of x. So y is equal to 3 sine inverse of x. This is your given function now. Actually we converted the complex form into simple form. Now differentiate with respect to x. Differentiate with respect to x on both sides, right? On both sides. Then what happens? Till now we didn't differentiate it, right? Just we simplified the problem, given problem. If the given problem is in complex form, simplify it by using substitution method. Once it is simplified, you apply your differentiation. That is the procedure. Okay, so come on, it is dy by dx is equal to d by dx of, what is that value? 3 sine inverse x. Okay, so 3 into d by dx of sine inverse x is equal to 3 into 1 by root of 1 minus x square. So you can write 3 divided by 1 minus x square. That is the answer. Okay, so this is the procedure. Now come to your second question. What is your second question? We will take 3 parts now, right? We will solve all the problems. We will try to solve all the problems in one board. Come on, second one. What is the given function to you? It is y is equal to cos inverse of 4x cube minus 3x. Okay, so same thing, it is in complex form. Only in cos inverse no problem, minus 1 by root of 1 minus x square. But here it is a cos inverse of 4x cube minus 3x is there. Okay, so whenever it is like that, you take x is equal to cos theta. So you can ask the question, how we will know, madam? So with the practice you will know it, and if you know the trigonometric formulas, we can easily by substituting. Actually outside it is cos inverse. So I said whenever cos inverse is there, sin inverse is there, tan inverse is there, beside that try to get its respective value only. That means cos inverse you try to get in terms of cos, so that cos inverse cos will get cancelled. Same sin inverse, suppose sin, convert it, decide it into sin, so that sin inverse sin will get cancelled. Like that we have to take. So for that sake, x is equal to, put x is equal to cos theta here. Then what happens to your y? Y is equal to, it is cos inverse of 4 cos cube theta minus 3 cos theta. Okay, so again there is one formula. What is that formula? From trigonometry, it is cos inverse. This one is cos 3 theta. So I said no, inside, whenever outside cos inverse is there, try to get the value in the bracket in terms of cos only, so that cos inverse cos will get cancelled. So you will have 3 theta. So from this, what is your theta? Send cos this side. Then it will be cos inverse of x is equal to theta. Okay, so is equal to, it is 3 into, what is theta? It is cos inverse x. This is your y. So we simplified the problem now. Now differentiate with respect to x on both sides. X on both sides. So what happens? It will be dy by dx is equal to d by dx of 3 into cos inverse x. So 3 into d by dx of cos inverse x. Come on, take the formula. 3 into d by dx of cos inverse x is minus 1 by root of 1 minus x square. So is equal to, it is minus 3 by root of 1 minus x square is the answer of this problem. Almost first and second are same, but repeated questions, that's why I am giving. Otherwise I can give this as homework also. Now come to the third one. What is the third question? Come on, what is that? Sin inverse of 2x by 1 plus x square. Whatever be the given function, you consider that as y. Y is equal to, it is sin inverse of, come on, 2x by 1 plus x square. So whenever it is sin inverse, inside the brackets we have to get sin, so that sin inverse sin will get cancelled. So any formula is there, so that if we substitute in x place, we can get a sin. Yes, it is there, right? What is that? You put x is equal to tan theta now. Why? In trigonometry, you know it, this formula. Y is equal to sin inverse of 2, I am substituting in x place, tan theta now. 2 tan theta by 1 plus tan square theta is equal to sin inverse of sin 2 theta. Okay, this is sin 2 theta. So is equal to, it is 2 theta is equal to 2 into theta. What is theta? We can write from this, send tan this side. What happens? It is tan inverse x is equal to theta. So we can write that as 2 tan inverse x. Okay, so it is simplified. Now differentiate with respect to x. With respect to x on both sides. Come on, it is dy by dx is equal to d by dx of 2 into tan inverse x. Whenever some constant and function is there, we will write constant outside and we will differentiate the function, isn't it? So it is d by dx of tan inverse x. I said most repeated formula in differentiation. So it is 2 by 1 plus x square. That is the answer of your question. Okay. So now come to fourth one, right? This is first one, second one, third one. Is it clear? So whenever the given problem is in complex form, first we have to simplify by using substitution method. Instead of x, we will take some value in it, right? So then we will substitute and we will simplify. Okay. So now come to next one. What is that? Fourth question. Okay. So what is that fourth question? See the fourth one. It is secant inverse 1 by 2x square minus 1. So take that question, fourth question. It is fourth one is y is equal to secant inverse 1 by 2x square minus 1. Same thing in these problems, whenever it is in complex form, maximum if it is inverse form, we are using substitution method so that we can cancel that inverse and we will have simple problem, simple question, right? So here you put x is equal to cos theta now. X is equal to cos theta. Then what happens to your y? Y is equal to, come on, it is secant inverse 1 by 2 cos square theta minus 1. Okay. So is equal to, it is secant inverse 1 by, what is this? 2 cos square theta minus 1 is a standard formula in trigonometry, that is cos 2 theta. So is equal to secant square into 1 by cos 2 theta, right? 1 by cos 2 theta is nothing but secant 2 theta. Secant inverse secant 2 theta is 2 theta. So is equal to 2 into, come on, how we will get theta? Same thing, send cos this side. All are having same procedure, isn't it? So send the cos this side. Cos inverse x is equal to theta. So in theta place we will take that value cos inverse x. That is your y. Okay. So differentiate with respect to x now. Same, once it is simplified, you differentiate with respect to x on both sides. Okay. So it will be dy by dx is equal to d by dx of 2 cos inverse x. Whenever some constant is there, function is there, we have to write constant outside. So 2 into d by dx of cos inverse x is equal to 2 into minus 1 by root of 1 minus x square is equal to, it is minus 2 by root of 1 minus x square is the answer of this question. Okay. So slowly by practicing these problems, just by seeing the problem, you will get the idea. Here whenever inverse problem is there, we have to go for substitution, so that actually if it is in simple inverse form, no need to go for substitution, directly we can solve the problem. But whenever it is in complex form, we have to go for substitution. Okay. So now come to fifth question, right? What is your fifth question? If y is equal to e to the power of a sine inverse x, right? Then prove that. So one advantage is there in prove that and show that problems. Before solving that, you will know your answer, right? So we have to differentiate with respect to x on both sides. Come on. dy by dx is equal to d by dx of e to the power of a sine inverse x. Okay. So in differentiation we are having one standard formula, d by dx of e to the power of x is equal to, that means exponential function, variable as some variable, power as variable, then e to the power of x into d by dx of that variable. So instead of x, here we are having this one. So is equal to e to the power of a sine inverse x into d by dx of a sine inverse x. So come on, is equal to e to the power of a sine inverse x is y, okay, into a is constant into d by dx of sine inverse x. Okay, so is equal to, it is ay into d by dx of sine inverse x is 1 by root of 1 minus x square. So we can write this as ay by root of 1 minus x square. That is the answer of your question. Okay, so very simple. This is not inverse problem, this is normal problem. Prove that problem, right? So whenever prove that, show that, we will be lucky, we will know the answer, isn't it? If we get anything differently, we can check once again, isn't it? So this is your given question. Find, show that dy by dx is equal to, so differentiating with respect to x on both sides. So this is the standard formula we used. Okay, so these are the questions today. Okay, 5 questions we did it. First in 4 questions inverse problems, and inverse of in bracket some complex form is there. So whenever problem is given little bit in complex form and inverse is there, then we will substitute. And suppose outside sine inverse of something is there, inside the bracket try to bring in terms of sine, so that sine inverse sine will get cancelled, we will get some simple formula, rough form, right? Then you differentiate it, you will get your answer. Okay, so those are the first 4 questions, and 5th question is normal differentiation. We used d by dx of e to the power of x, right? Exponential, power is variable, right? Then it is e to the power of x into d by dx of variable. So in variable place we are having a into sine inverse x. So you take d by dx of a sine inverse x. So a into d by dx of sine inverse x is 1 by root of 1 minus x square. And you know that this is our y. So in its place I have taken y. Okay. So practice these problems. That's all for today. Have a nice day.